Welcome back. This is Mr. Takeda Teaches Math 7, and this is lesson 10.3 on experimental and theoretical probability. Our essential question today is how can you use relative frequencies to find probability? What's relative frequency? That's not the number of times your cousins come over to visit you. Get it, relatives? This is relative frequency is when you're doing an experiment. When you're doing an experiment, it's when you're looking for a particular event, it's the number of times the event occurs divided by the number of times you conduct the experiment. So in other words, it's a fraction of part over whole. Okay, part over whole. Let's take a look. Experimental probability. So let's say you roll a dice and you want to know, and your experiment is to see how many times a 1 comes up. And the 1 comes up 30 times out of 100. Well, you would have 30 times over 100. You would have 3 out of 10. That's a lot. But just as an example, okay, so probability of the event, so we use the P again to show probability. In the parentheses, the event is what we're looking for, or what we're trying to measure. The number of times the event occurs divided by the total number of trials. So let's take a look at some examples now, shall we? Example 1, finding an experimental probability. The bar graph shows the result of rolling a number cube 50 times. Wow, 50 times. Can you even imagine that? What is the experimental probability of rolling an odd number? Okay, so here's our odd numbers, the 1, the 3, and the 5. How many times did they come up in these 50 rolls? Well, the 1 came up 10 times. The 3 came up 8 times. And the 5 came up 11 times. 29. So the probability of odd is going to equal 29 out of 50. 29 out of 50. And that's going to be, I don't know, whatever 29 times 2 is, I suppose, right? 29 divided by 50, 58% equals 0.58. So 58%. Or, yeah, I don't know if we can reduce 29 to 50. 29, because 29 is prime. So 29 out of 50, or 58%. Try this one. Using the same bar graph, what is the experimental probability of rolling a prime number? Now, if you forgot what a prime number is a number that can only be divided by itself. In these lower numbers here, 2, 3, and 5. 2 is the only even prime number because all other even numbers can be divided by 2, so it makes it not prime. It's called composite. Okay, pause the video here, figure this one out, put your answer down, and then join me on the next. Here we go, making a prediction. It rains 2 out of the last 12 days in March. If this trend continues, how many rainy days would you expect in April? Well, let's set up a ratio first. 2 rainy days out of 12. So so we're going to say P rain, right? P rain for March 2 out of 12, 1 out of 6. Okay, so the probability of it raining is 1 out of 6. We're going to use this to predict how many rainy days would I expect in April. Well, according to this calendar, there's 30 days in April. So 1 out of 6 equals some number, I'll use X, out of 30. Well, with these numbers, I think it's kind of easy to see we can kind of use the equivalent fraction method, right? I can say 6 times 5 is 30. So 1 times 5, well, that would make X equal to 5. So 5 days. You could also use the cross product method if you choose to do that. That works as well. take a look at this problem. I'm not going to read it to you. You can try reading this to yourself. Pause the video here, finish this one, and join me on. Okay, now let's talk about theoretical probability. Theoretical probability, it's very similar to experimental probability, except we're not running an experiment. We are looking at all of the outcomes. This is kind of like what we did in 10.2. This is basically what we did in 10.2. But we're looking at the number of favorable outcomes divided by the number of all possible outcomes, right? So this is the theoretical probability. So this is not the results of an experiment. It's just looking at all of the outcomes. So let's get this down. Okay, so let's find this theoretical probability here. You randomly choose one of the letters shown. What is the theoretical probability of choosing a vowel? All right, so we're going to try and calculate p-vowel. P-vowel. Well, I've got 3 vowels here. Those are our favorable outcomes because we're looking for choosing a vowel. So there's 3 vowels. How many possible things could I have chosen? I could have picked from 7 different blocks here, so 3 out of 7. So the probability of a vowel is 3 out of 7s, or that's going to be equal to 3 divided by 7. About 48%. I'm going to round this. It's about 43%. I'm sorry, 43%. I come up with 42.8, but we can round that to 43%. Okay, so again, it's just it's just a fraction. We're just going to divide here. Oops, not that one. Let's see. I think that's going to be it for this video. Actually, let me back up to here. That's going to be it for this video. Join me in class. I'm going to do this one in 2 parts, and I'll see you in class. Bye-bye.